Hello future engineers, subscribers, viewers, and students. Here is another video in algebra, the application of the concept on tangent lines to circles. So this falls under analytic geometry, supposedly. So here we go. One circle has a radius 2 units and center at the origin, while the other has a radius 4 units and center at 8, 0. Find the equations of the two external tangents and the two internal tangents. So to help analyze this problem, we have to plot the two circles and draw the two external tangents and the two internal tangents, so that for those who are not familiar with the definition of external and internal tangents, you will be informed and you will know. So one circle is at with radius 2 and center at the origin as shown. The other at 8, 0 and radius 4 units as shown. So this is the external tangent 1 externally, tangent 2 externally, then internal tangent with positive slope as shown, and another internal tangent with negative slope, the negative of the slope of the internal tangent I. So we have to draw the points, locate the points of tangency as shown, and the radius, so that we can analyze this equation. So this is 2 units, radius 2, 4 units, distance between centers 8. So if we draw a line from the center of the smaller circle perpendicular to this radius here of 4, then that line will be parallel to this tangent line, tangent 1, external tangent line. And therefore, the slope of that line is also the slope of this line here. We can analyze the angle that this dashed line parallel to the first external tangent as the tangent of the angle it makes with the x-axis, positive x-axis. So if we call that theta I, take note that's 2 and the hypotenuse is 8 and that's 4. So sine of theta E1 is equal to 2 over 8, and 2 over 8 is 1/4 actually. So therefore, if this is 1, we can reduce this to 1, this is 4, then this adjacent side would be square root of 4 square, which is 16, minus 1 square, which is still 1. So square root of 16 minus 1 is square root of 15. So this is square root of 15. The slope of this line, therefore, is the tangent of theta E1, which is equal to opposite 1 divided by square root of 15. So slope of external tangent 1 is tangent of theta E1 is 1 over square root of 15. Remember, we reduced this to 4, we reduced this to 1, and therefore the length of this is square root of 15, and tangent of theta E1 is opposite, which is 1 over square root of 15. So that is also the slope of the external tangent 1. The slope of the external tangent 2, which is this, is the negative of that. This is because this is positive. This is inclined up to the right, so the slope is positive, while this one is inclined down to the right. So the slope is the negative of that, and the angle it makes with the horizontal or x-axis is the same. So that's why M2E is equal to negative 1 over square root of 15. The expected equation of this tangent external 1 is x minus square root of 15y equals x1 minus square root of 15y1. So take note of that technique. That is also point slope form technique. So we need to express the coordinates here. I'll call this x1, y1, and it lies in the second quadrant, therefore x1 is negative and y1 is positive. So the ratio of x1, because this is also theta e1, this angle with that the radius makes with the vertical line, the y-axis, is also theta e1, and that is equal to opposite over adjacent. Since the opposite side is x1 and it is expected negative, adjacent side is y1, therefore x1, so this is negative x1 over y1 equals 1 over square root of 15, because we anticipate that x1 is negative in the second quadrant. Take note of that. So therefore, x1 is negative of y1 over square root of 15. We then substitute it into the equation of the circle, which is x squared plus y squared equals radius square for circle with center at the origin. So x squared plus y squared equals 2 square, and x1 is equal to this. So negative of y1 over square root of 15 square plus y1 square equals 4 or 2 square. So this is y1 square over 15, or y1 square over 15 plus y1 square, that's 16 over 15 y1 square equals 2 square after we combine these two. So y1 therefore is plus minus, supposedly plus in the second quadrant, but in the other point of tangency by symmetry is here, where both x1 and y1 are negative. So x1 is negative here and y1 is also negative at this point of tangency. So that's why y1 is square root of 15 over 2 plus minus square root of 15 over 2, because this is 2 square over 16, 1/4 times 15. So square root of 15 over 4 is plus minus square root of 15 over 2. So y1 is plus minus square root of 15 over 2. So we first consider this point, which is negative. Let's solve for x1, by the way. x1 is negative of quantity y1, which is square root of 15 over 2, y1 over square root of 15. So x1 is 15 over 2, negative 15 over 2. Sorry, 1/2, negative 1/2, because we can cancel square root of 15. So x1 is negative 1/2. Again, the expected equation of the external tangent one is x minus square root of 15y equals x1, which is negative 1/2, minus square root of 15, and y1 is positive square root of 15 over 2. So x minus square root of 15y equals negative 1/2 minus 15 over 2. That's negative 8. So therefore, the equation of the external tangent 1 is x minus square root of 15y equals negative 8. So that's the answer for this case. For this tangent, external tangent 2, the expected equation, because the slope is equal to this, so x plus square root of 15y equals x1 negative 1/2 plus square root of 15 y1, which is negative square root of 15 over 2 this time, because this is the other point of tangency, x2 comma y2. x2 is still equal to x1, which is negative 1/2, but y1 is this time negative, y2 is this time negative, negative square root of 15 over 2. So x plus square root of 15y equals negative 1/2 minus 15/2. So x plus square root of 15y equals negative 8. So that's the external tangent 2. We then proceed to the analysis of determining the equation of tangent internal 1. So imagine we have a radius here of 2 perpendicular to this tangent, and radius here of 4 perpendicular to this first internal tangent, and we just extend that. So we draw another line intersecting the line or radial line from the center of the bigger circle extended there. So that extension is equal to this radius here, which is 2 perpendicular to this tangent line, and these radii are also perpendicular to this tangent line. So therefore, these two lines, this one is parallel to the internal tangent 1, because this is 2 and that is also 2, and this is 4 extended, so they are perpendicular, and this line here is parallel to this tangent line. So whatever is the slope of that line, that's the slope of the internal tangent 1. So this is 8. Remember, this is 4 and this is 2. So this is 6. Therefore, this side is square root of 8 square, which is 64, minus 4 plus 2 minus 6 square, which is 36. 64 minus 36 is 28. And square root of 28 is 2 square root of 7. 4 times 7, square root, so 2 square root of 7. So that's 2 square root of 7. Therefore, if we call this theta I1, or theta internal tangent 1, then tangent of theta I1 is opposite, which is 6 divided by adjacent 2 square root of 7, and opposite 6 over 2 square root of 7 is positive because the slope of this line, which is equal to the slope of this internal tangent 1, is positive. It is inclined up to the right. So it is 6 over 2 square root of 7. Slope of internal tangent 1 is 6 over 2 square root of 7, or 3 over square root of 7. I will not simplify that. The slope of the internal tangent 2, which is this, is, because the angle is the same except that this is counterclockwise and this is clockwise, they have the same slope numerically, but this one is negative. It is inclined down to the right. So the slope of the internal tangent 2 is negative 3 over square root of 7. The expected equation is for internal tangent 1 is 3x minus square root of 7y equals 3x1 minus square root of 7y1. But I use the other technique from analytic geometry in finding this equation. You may use this technique here, which I used in arriving at the slopes or equations of the external tangents, the two external tangents. But this time I'll use the concept that for this circle rather, x squared plus y squared equals 2 square. I replace x squared by x1 and y squared by y1. So let's find the x. I'll call this point of tangency x3 comma y3, rather, to differentiate it from the point of tangencies x1, y1, and x2, y2 previously. So I'll call this x3, y3, and this one x4, y4. But we use the same concept. So take note that the ratio for tangent internal 1, the point of tangency x3, y3 is in the fourth quadrant where x is positive and y is negative. So y is negative, so x3 over negative y3 is equated to the slope of the internal tangent, which is 3 over square root of 7. Therefore, the value of this is theta I1, theta I1 also. So that's why tangent of theta I1, which is this, is equal to opposite which is x3 positive over this, which is y3, and y3 is negative. So we anticipate that. So that's why x or y3 is negative square root of 7 x3 over 3. Then we substitute that into x3 square plus y3 square equals radius square 2 square. So we substitute that into this equation here. We just replace x by x3 and y by y3 quantity square. So this is 7 over 9. 9 times 1, 9 plus 7, 16. 16 over 9. x3 square. So x3 square plus 7 over 9 x3 square equals 4 or 2 square. Multiply everything by 9. So 16 over 9 x3 square equals 36 after we multiply everything by 9. So that's why x3 is square root of 36 over 16, and that's 6 over 4, and 6 over 4 is 6. 36 square root of 36 is 6. Square root of 16 4. That's why it's 6 over 4 or 3 halves. So x3 is plus minus 3 halves. But this is the point of tangency here. Point of tangency. So therefore x3 is positive. But y3 is negative. y4 is positive because the other point of tangency for the internal tangent 2 is in the first quadrant. So y3 is negative square root of 7 over 2 from this equation because x3 is 3 halves. So if we replace this by 3 halves, we can cancel 3. So that's why y3 is negative square root of 7 over 2, and y4 is positive square root of 7 over 2 in the first quadrant. So the expected equation is, so this is a 3 halves comma negative square root of 7 over 2, while that point is 3 halves comma positive square root of 7 over 2. So this is the other technique. x3 plus y3 equals 2 square. For the internal tangent 2, x4 plus y4 equals 2 square. So x times x3, which is 3 halves, plus y3, which is negative square root of 7 over 2 equals 2 square or 4. Multiply everything by 2. So the equation of the first internal tangent is 3x minus square root of 7y equals 8. 3x minus square root of 7y equals 8. So that's the equation of that internal tangent 1. For the internal tangent 2, remember the point of tangency here is 3 halves comma positive square root of 7 over 2. So x 3 halves plus y square root of 7 over 2 equals 4. And therefore, the equation after multiplying by 2 is 3x plus square root of 7y equals 8. So that's the equation of the internal tangent 2. So that's it for this video.